For the first question, it tells us the coordinates of point A, and we need to find the coordinates of point B prime after a dilation centered at the origin occurred. So the rule for a dilation centered at the origin is that you can take each of the points and multiply by the scale factor. So if the coordinates of A prime are -4, 2, to get from A to A prime, what happened is that the x coordinate multiplied by 2 and the y coordinate multiplied by 2. So in order to find the coordinates of B prime, we just need to do the same thing. We need to take the x coordinate of B and multiply it by 2. So 2 times 2 would be 4. And the y coordinate of B and multiply it by 2. 4 times 2 would be 8. And that's answer choice number 2. In question number 2, we are taking a cross section parallel to the base. When you're taking a cross section parallel to the base, it will be the same as the base. And you can think of it as cutting it horizontally with a plane. And I'm really bad at drawing because it's supposed to look like this over here, but I'm really horrible at drawing. Let me try that one more time and see if I can make it look the same. No, not gonna happen. I'm horrible at drawing. That's as good as it's gonna get. But whenever you're cutting parallel to the base, it'll be the same as the base. So it will be a square here because it's a square pyramid. So the base is a square. Here we have a dilation. So remember that before and after a dilation, corresponding angles are congruent and corresponding sides are proportional. So what that means for trig ratios is that if you are using a congruent angle in each of the triangles, then the trig ratio will be the same. Because if you're using the same angle, then the sides are proportional, so you'll end up with the same trig ratio. So just to see this a little bit clearer, I'm gonna just separate the big and the small triangles. So here's triangle ABC. And here's triangle DEC. And since the dilation happened, dilations do make similar triangles. So the triangles are in fact similar to each other. And the way that we're going to figure out which statement is true is we're going to have to try out the answer choices. So all of the answer choices do have a focus angle at angle A. So I am going to just circle angle A. And that's the same as angle D, since corresponding angles are congruent and similar triangles. So those are both the same. So that means sine of angle A and sine of angle D should be the same. Cosine of angle A and cosine of angle D should be the same. So from angle A, I'm going to label opposite, adjacent, and hypotenuse. And I'm going to do the same thing from angle D, opposite, adjacent, and hypotenuse. And now I'm going to see if the first answer choice is true. Sine from angle A, opposite is BC, over hypotenuse is AC, because sine is opposite over hypotenuse. So I'm going to write that here. Sine of angle A is opposite over hypotenuse. That doesn't match up to answer choice 1 or answer choice 3. Let me also try it from the other triangle because remember sine of angle D is the same as sine as angle A because they're similar triangles. So opposite is would be EC, over hypotenuse would be DC, and that is answer choice number 1. So that is the correct answer here. If you try out cosine for angle A and for angle D, it won't match up to either answer choice 2 or answer choice 4. Those will both be incorrect setups. Okay. Oh, that was already 3. What is the minimum number of degrees needed to carry the pentagon onto itself? So what that means is that we're seeing how many degrees does it take to turn around that pentagon around its center so that it looks exactly the same, that it's facing the same way as the original, that it rotates back to the beginning. And we have an easy way of doing this. A full rotation is 360 degrees. So just take 360 and divide by the number of sides, which is the same as the number of angles. A pentagon is a five-sided shape. 360 divided by 5 is 72 degrees. And watch out for questions like this because sometimes 72 degrees wouldn't be an answer choice. Here it says the minimum number of degrees. So the first time it happened, so that's why it's here. But in other questions that don't say minimum, it might be a multiple of 72. Because remember, any multiple will result in the same figure as the original. Here we have some congruent figures, and it's asking us how triangle ABC became triangle A prime, B prime, C prime. So I'm looking, and I know right away that this was not just a reflection. And the reason I know it was not just a reflection is because if you imagine triangle ABC flipping over a line, and I'm just going to draw it. I don't know what line it's going to flip over, but I'm just going to draw you a picture over here. C is going to flip over and go here. Let's say the line is here. B is going to flip over and go here. And A is going to flip over and go here. But over here, that's not A prime. And over here, that's not B prime. So it's not oriented the same way that it would be if a reflection happened. So by just thinking about and drawing out where the points are going to go if a reflection happened, I can eliminate answer choices one and two right away because a reflection didn't happen. So we're between the answer choices three and four. They're both a rotation of 180 degrees. So luckily, that makes our life easier because we just have to see the center point. So one suggested center point in answer choice four is the origin. And to me, it's looking like the origin is closer to the image triangle than to the pre-image triangle. So it doesn't look like it's like in the middle of the two. So that looks a little off to me. Let me check out the center in answer choice three. 1, 1. That looks more equidistant to me, so I'm leaning towards answer choice three. But let me just try out rotating a point to see if it lands in the right spot, just so I know for sure. So I'll do eight where A prime is gonna go. So that L shape looks like this. One, two, three, four, five this way, and one this way. If I rotate 90 degrees, and it doesn't matter the direction because 180 counterclockwise or clockwise is the same thing. So if I rotate 90 degrees and I'll just rotate clockwise, we have this. And if I rotate again, we have this. And that should be our movement. So I'm going to start at the center and I'm going to do that movement. One, two, three, four, five, and one down. And I do land over here on A prime, but I know it could be tricky to do rotations on the grid. I always like to try it out just to see if it'll land where it's supposed to land. But for this type of question, if you didn't know how to do the rotation, you can use the reasoning that we used here, that the center point should be in between both of the triangles, and the origin was closer to one of the triangles than the other triangle, so it wasn't going to work here. Right triangle, TMR, is a scalene triangle with a right angle at M. Which equation's true? So if it's a right triangle, that means these two angles together, whatever they are, have to make 90 because in total, all three angles of a triangle make 180. And if we already have a 90-degree angle at M, then T and R also need to make 90 because 90 plus 90 makes 180 degrees for the total triangle. So what I know is that when we have complementary angles in a right triangle, we have co-functions that are true. So remember, sine and cosine are co-functions, and that means that they are equal when their angles are complementary. So since angle T and angle R are complementary, sine and cosine of the two angles are going to be equal to each other. So I want one that has sine of t and cosine r, or sine of r and cosine t. So I don't want with the same angles. I don't want with the 90-degree angle. I want answer choice number three. And that just illustrates the co-function relationship between sine and cosine. They're equal when their angles are complementary, and T and R are the complementary angles. Which statement's always true? We're given that AE is congruent to DE. Always mark your diagram with the given information. That's how a lot of people run into issues by not marking their diagram. So just make sure you mark your diagram. If I redraw the other triangle for you for a second, so triangle AED, what the given information told us is that this triangle has two equal sides. So it's isosceles. And we know that when we have isosceles triangles, the base angles are congruent, the angles opposite from the congruent sides. So in this diagram, that would be angle A and angle D, or with three letter names, angle EAC and angle EDB. And that's answer choice number 4. That's really the only thing I can know for sure here because they gave us the given information about the two congruent sides. They didn't give us anything else to go off of. So that's really the only thing I can figure out here. In number 8, we have that we are rotating the triangle around side AC. So always draw a picture. Here's side AC. I'm going to highlight it. You can imagine a flag spinning around the flagpole really, really fast so that you'll start to see it on both sides of the flagpole. And the straight edges start to look curved. So what you have here is a cone. And anytime you're rotating a triangle from 2D to 3D, it will be a cone. Anytime you're rotating a rectangle from 2D to 3D, it will be a cylinder. You can think of folding a piece of paper to get a cylinder. So what we have here is we have a right cone. So we don't have a cylinder, we have a right cone. That just means it's standing up straight with a right angle, and we do have a right angle there, with a radius of 15 and a height of 8. So make sure you draw a picture. Easy question if you just draw a picture. Which statement is sufficient to prove that ABCD is a parallelogram? It just tells us in the question that lines K and L intersect lines M and N at points A, B, C, and D. So they don't tell us that the lines are parallel. So in order to have a parallelogram, what a parallelogram is, what the definition of a parallelogram is a quadrilateral with two sets of parallel sides, two sets of opposite parallel sides, I should say. So I need an answer choice that's going to prove that AB is parallel to DC and AD is parallel to BC because the answer choices are all angles and angle relationships can prove lines parallel. Specifically, alternate interior angles being congruent can prove lines parallel, and corresponding angles being congruent can prove lines parallel. Let's check out what we have here. Answer choice 1. Well, I don't think that's going to be enough because I only got one pair of angles. But let's check it out. Angle 1 congruent to angle 3. Those are corresponding angles formed by these two lines. So that would prove that AD is parallel to BC. But it wouldn't prove that AB is parallel to DC. So that's not going to be enough. Angle 4 congruent to angle 7. Those are alternate interior angles. And here's the letter Z. So that proves that AB is parallel to DC, but it doesn't prove that the other set of lines AD and BC are parallel. So we really need the one with two sets of angles. Let's check out answer choice number 3. Angle 2 is congruent to angle 5. Those are alternate interior angles. And here's my letter Z. So that proves AB is parallel to DC. And angle 5 congruent to angle 7. Here's angle 5. And here's angle 7. Those are corresponding angles with these two lines. So that proves that AD is parallel to BC. So answer choice 3 is the one that we need. The reason why answer choice 4 is not the correct answer choice is because angle 1 congruent to angle 3, those are corresponding angles proving that AD is parallel to BC. But angle 3 congruent to angle 4, Those are vertical angles. Vertical angles are always congruent. They don't prove lines parallel. Which transformation does not always preserve distance? The answer to this one is 3 because we are multiplying the x coordinate by 2, so it's making it bigger. It doesn't preserve distance if it's making it bigger. That's a dilation. So I'm going to put that over here. That is a dilation. Here we have EF parallel to HG. And the reason that they give us that information is because from that, we have parallel lines, so we can say the alternate interior angles are congruent. We do have a letter Z, so we do have those congruent alternate interior angles. And then we do also have the vertical angles, which are always congruent. So we have AA, and that tells us that the triangles are similar. And that's helpful because now that we know the triangles are similar, we can set up a proportion because corresponding sides of similar triangles are proportional, and we can make a proportion in order to solve for the missing side length of the triangle. So now all I need to do is make a proportion in order to solve for HI. So let me set up my proportion over here. So I'll use 5 and 12. They correspond. So I'm doing small over big. So I got to do small over big again. I'm going to do 1.4x plus 3 over 6.1x minus 6.5. And this is just going to be a little bit annoying with the algebra. So let's write it out. 5 times 6.1x minus 6.5 equals to 12 times 1.4x plus 3. So just be careful and make sure that you distribute the 5 to each of the things inside the parentheses as well as the 12. So 5 times 6.1, that's 30.5x. And then 5 times negative 6.5 is negative 32.5. And 12 times 1.4x is 16.8x. And then 12 times 3 is 36. And now I am going to add 32.5 to both sides. And I get 30.5x equals 16.8x plus 36 plus 32.5 is 68.5. And now I'm going to subtract 16.8x from both sides. And I'm going to just move over here so I have a little bit more space. So 30.5 minus 16.8x, that's 13.7x equals to 68.5. So now I'm just going to divide both sides by 13.7. 68.5 divided by 13.7. And that works out really nicely to 5. And just double check the question because an answer choice here is 5, but it's asking you for the length of HI, so you do have to plug in because HI is represented as 6.1x minus 6.5. So you do have to plug that 5 in order to see what HI is. 5 times 6.1 is 30.5 minus 6.5 is 24. So the length of HI is 24. Make sure you double check what the question's asking for. If you have time on your Regents exam, go back, look at all the questions and see that you answered the question that was being asked and that you rounded appropriately if it's a short response question, because you don't want to lose the points on that for accidentally picking answer choice number 2 because that was the X value. For number 12, we have a square pyramid and it's talking about density. And I know density is equal to mass over volume. That's not provided to you on the Regents exam, so you do have to know that. So I know that I'm going to need the volume of the pyramid. So the volume of a pyramid formula is provided to you on the Regents exam. It's 1/3 capital B times H. Remember that the capital B stands for the area of the base. And since we do have a square base here, with each side that measures 4.5. The area of the square base would be 4.5 times 4.5. I'm going to do that in my calculator, 4.5 times 4.5, and I get 20.25. So I'm just going to substitute that into the formula right now, 20.25. And then I need the height of the pyramid, which is given to us as 10 centimeters. So they give us that the height of the pyramid is 10 centimeters. And so far, everything was in centimeters. The sides of the base were 4.5 centimeters, and the height was 10 centimeters. And if I quickly glance at the density, the volume unit, because the first unit with density is mass and the second unit's volume. So the volume unit is cubic centimeters, so that means everything should be in centimeters, so we're good to go. We don't need a conversion for this question. So let me plug into the volume formula. So I'm going to just type it into my calculator. And I got the volume of the pyramid is 67.5 cubic centimeters. That worked out nicely. So now going back to my density formula, and now I'm just going to move it up so I have more space. Our density is 0.676 grams per cubic centimeter. We are looking for the mass, and the volume is 67.5 cubic centimeters. And the cubic centimeters cancel out, and our answer will be in grams, just like the question's asking for. You can put this over 1 and cross multiply. So mass is equal to, in your calculator, you just need to multiply the 67.5 by the density, which is 0.676, and that is 45.63. And to the nearest tenth, that is 45.6. And that is our answer here. For number 13, we have a big right triangle because it says right triangle EFG. So triangle EFG is a right triangle. And we have altitude FH, and altitude is a perpendicular line. So where altitude FH intersects hypotenuse EG, it forms right angles since it is a perpendicular line. So what we have here is we have a big right triangle with two smaller right triangles inside of it formed by the altitude. Anytime you have this situation, you do have similar triangles. That's because all three of the triangles have a right angle and all right angles are congruent. And because since the smaller triangles are inside the big triangle, they each share an angle with the big triangle, so that's reflexive property. So we have AA proving the triangle similar. So as long as when you see this type of situation, you recognize that you have similar triangles, that's really all you need in order to answer the question. What we're going to do in order to make sure that we put our corresponding parts in the right order is we're going to take each of the triangles and we're going to redraw them so that way they're facing the same direction because otherwise it's really easy to mix up the corresponding parts. So I'm going to draw them all with the right angle in the same spot. So I'm going to do EFG first, the big triangle. So the right angle is at F, and it doesn't matter where you put E or G for the big triangle. It does matter for the other triangles, though. So for the other triangles, it is going to matter. Next, we'll do the medium-sized triangle. So we'll do triangle EFH. And I'm going to draw it facing the same way as the big one. The right angle for triangle EFH is at H. And I'm going to think about what angle this triangle shares with the big triangle. And it shares angle E with the big triangle. Be careful, it doesn't share angle F. In the big triangle, angle F is the whole right angle. But in this triangle, it just has a piece of angle F. So that's not shared. So since it shares angle E with the big triangle, since we put angle E here in the big triangle, we have to put it in the same spot because it's supposed to match up. These are similar triangles here, and they do share that angle. So it's got to match up. And then finally, we can do the small right triangle, and we're going to draw it facing the same direction. The right angle for this triangle is once again at H, and this triangle shares angle G with the big triangle. Since we put angle G in this spot in the big triangle, we have to put it in the same spot in this triangle because it's shared, it corresponds, it needs to match up in the two triangles. And that leaves F to be the last point here. Now, all I'm going to do is I'm going to put the measurements into both the original triangles and also into the separated triangles, and then we can make our proportion and solve. Sorry, I have a bit of a cold today. FH is 9. On the separated triangles, I see FH over here. Oh, I forgot to put the last letter in the blue triangle. So we do also have FH in the blue triangle. So I'm going to put the 9 there as well. And EF is 15. EF is over here in the big triangle. And it's also a side of the blue triangle. And we're looking for EG. So EG is the side of the big triangle. So what I need to do here is I need to set up a proportion with two of the similar triangles here in order to find what I'm looking for. So what I'm thinking is because it looks like it's going to be a little difficult for us to find EG right off the bat. What I'm thinking is maybe we could find EH and HG and then put them together because EH, or once we find EH, we should have enough information to find EG. So let's find EH first. So let's find EH. That blue triangle is a right triangle, so we can use Pythagorean theorem. So I'm going to do a squared plus b squared equals to c squared. Be careful, 15 is the hypotenuse, so you do need to plug that in for the hypotenuse. So that's 81 plus b squared equals to 225. On your calculator, if you do 225 minus 81, you get 144, and that works out nicely. If you square root both sides, you get 12. So the length of EH, oops, I didn't want to delete that entire triangle there. The length of EH is 12. And now we have enough information to set up a proportion to find EG because now I have two corresponding sides of the black and the blue triangle. I can use the 15, and that corresponds to the 12 that we just found because they're both on the same side of the two triangles. And then X is what we're looking for, and that corresponds to the 15. So from here, we can cross multiply. We have 225 equals to 12x. And then in my calculator, oh, why is that not writing? 12x, there we go. And then in my calculator, I can just divide 225 divided by 12. And then I get x is equal to 18.75. This one was a little tricky because you didn't have enough information to make a proportion right off the bat. So I think the most direct way was to use the Pythagorean theorem to give yourself enough information to make that proportion. Not the only way to do it, but definitely a way that works. And redrawing the triangles is definitely helpful. Okay, let's check out the next example. So in the next example, we are told that DE is parallel to BC. So definitely mark that in the diagram. People often don't want to mark parallel lines for some reason, but definitely put it in. So that's pretty much all the information that we have from the givens, but that's a lot of information because when you have parallel lines, you have angle relationships that are true. And that's often why they give you parallel lines because it's parallel lines cut by a transversal. And here what we have is we have corresponding angles. There's also corresponding angles on this side as well. And there's also the shared angle between the two triangles. They both share angle A. Angle A is an angle in the small triangle ADE, and it's also an angle in the big triangle ABC. So there's actually three pairs of congruent corresponding angles, but all you need is two pairs of congruent corresponding angles in order to establish that the triangles are similar to one another. Be careful. Answer choice three looks like a tempting answer choice. That would be true if DE was the midsegment of the triangle. They draw the diagram to make it look like DE is a midsegment. That point D and E are midpoints, that it's in the center of the triangle, because the midsegment of a triangle is half the length of the base and also is parallel to the base. So they give you that choice to be tricky. But in the question, it never says that point D and E are midpoints. It doesn't say that they split the line segments that they're on equally. So we have no reason to believe that DE is actually a midsegment other than the diagram. And we don't trust how diagrams look. They're not drawn to scale. So be careful of that. That was the trick answer choice here. And I guess you could say answer choice one is if you were trusting looks as well. Answer choice one would be trusting looks, but be careful, no perpendicular lines here. They didn't tell us that. Okay. If one exterior angle of a triangle is acute, then the triangle must be. These are hard to for me to do without guessing unless I draw a picture. So why don't you actually just draw a picture and just make the exterior angle, one exterior angle acute? 60 degrees is an acute angle, right? And then the angle right next to it inside the triangle will have a supplementary relationship with it, right? They form a linear pair. So together they make 180. So if you do 180 minus 60, that's 120 degrees. So that's an angle that's greater than 90 degrees. So I already know that this is an obtuse triangle because an obtuse triangle is a triangle that has one angle that's greater than 90 degrees. So draw yourself a picture. Sometimes the questions look tricky, but if you draw yourself a picture, it's actually not that bad. Which pair of triangles cannot always be proven congruent to each other? So these ones share a side. I have a right angle, so that's side, angle, side, side, angle, side. These ones are congruent by side, angle, side. They share a side as well by reflexive property. So we have side, 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 side. These two triangles are congruent by side, side, side. For the next answer choice, we have congruent vertical angles. Remember, vertical angles are always congruent. So we have angle, angle, side, angle, angle, side. So we have AS, that's good to go. Here, there's two sides in an angle, but the angle isn't between the two sides. It's not there. So what we have here is side, side, angle. And if you read that backwards, that is a bad word that you don't want to be putting on your geometry test. Side, side, angle does not prove triangles congruent. It's a false method. What is the vertical drop? This is a trick question. You do have a right triangle. The thing is they don't give you a focus angle inside the triangle, so you're gonna have to use your angle relationships here in order to figure out. So we can use the fact that angles that form a linear pair are supplementary. So these two angles next to each other are supplementary, so they need to add to 180. So this angle over here is 80 degrees. And you can use any angle as the focus angle except the 90-degree angle for trig. So I'm going to circle the focus angle, and from the focus angle, I'm going to label my sides opposite, hypotenuse, and adjacent. I'm going to write SOHCAHTOA on my paper, and I have adjacent, and I'm looking for the hypotenuse here. So that is going to be A and H, so that's going to be cosine. So cosine of the 80-degree angle is adjacent over hypotenuse. From here, we can put over 1 and we can cross multiply. 140 cosine 80 equals to x. You can put that into your calculator, and you should find that x is approximately 24 degrees. In this example, we need to find which sequence of rigid motions Sorry. Maps triangle LET onto triangle L double prime, E double prime, E double prime, T double prime, sorry. That means two transformations happened if you see a double prime, because if only one transformation happened, it would just be prime. Two transformations happened, so it's double prime. So a reflection over the x-axis followed by a reflection over the y-axis. This one's easy enough that we can actually just do it and see if it works, which is what I recommend doing. So let's reflect over the y-axis. 1, 2, 3, 1, 2, 3, 1, 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then we're going to reflect over the x-axis. One, oh, I missed the x-axis. 1, 1. Okay, already I can tell this doesn't land me where I need to go. T double prime is not where T double prime should go. So I don't even have to waste my time doing any more of this one. This one's done. It doesn't work. Okay. Um, the next one is a rotation of 180 degrees about the origin. So I'm gonna just try one of the points and see if it works. And if it doesn't work, then I'm gonna eliminate this answer choice. So I'm just gonna do E and see if it lands where E double prime is. So from the center to E, it's 1, 2, 3 up and 1 over. And that L shape kind of looks like this. And it says 180 degrees. So 90 degrees, and I'm just gonna do clockwise. 3 and 1. 3 and 1. So I'm going to start at the center and do that same movement. 1, 2, 3, 1. Does not land where it should land. And you might have been able to tell without trying out that rotation that because of the orientation of the points, a reflection is going to have to be involved here because the figure does flip over to get from LET to L double prime, E double prime, T double prime. So if it's flipping over, if it's not just turning, if it involves a flip over, um, then it's gonna need a reflection. So that means it's either answer choice 3 or 4. So let's check out answer choice number 3 and see where that lands. And since it does involve a rotation, I'm only going to rotate 1 point. So a rotation of 90 degrees counterclockwise about the origin. So I'm going to rotate E again. So that L shape is 3, 1. And it does say 90 degrees counterclockwise. So counterclockwise is we're going to go this way. 3, 1. So I'm going to start at the center and I'm going to do that movement. 1, 2, 3. 1. So that's where E double prime lands after that rotation. And followed by a reflection over the y-axis. So let's try that out. 1, 2, 3. 1, 2, 3. It lands where it's supposed to be. So that is the correct answer. If we look at answer choice number 4, if we were to reflect over the x-axis, it would bring us into this box. It would flip it over into this box, followed by a rotation of 90 degrees clockwise would bring us back into this box. So it wouldn't land you in the correct box. So sometimes you can use process of elimination with that for these multiple choice questions. I like to just try it out when I can. And if it's a rotation, I recommend just trying out 1 point. But also you can eliminate because you could think about where is it going to land. And if you have the general like quadrant that it's going to land in, you can think about, okay, if I do that, will it land in this box, even if I don't know exactly where it's going to land? Diameter, ROQ. of circle O is extended through Q to point P, and tangent PA is drawn. If measure of arc RA is 100 degrees, what is the measurement of angle P? So it's asking for the measurement of an outside angle. The measurement of an outside angle, so let me write that here, outside angle, is the same as with an inside angle, except instead of being half the sum of the intercepted arcs, it's half the difference of the intercepted arcs. And we do big arc minus little arc, so we don't end up with a negative value. So angle P is the outside angle, so angle P is equal to 1/2 um, big arc, which is RA, which is 100, minus little intercepted arc. Little intercepted arc would be 8Q. And since we did have a diameter here, we know the whole way around is 180. So 8Q is going to be 80 degrees. So 100 minus 80 is 20. So half of 20 is 10 degrees. So we do have 10 degrees for angle P. Segment JM has endpoints that are given, and we need the equation of the perpendicular bisector. A perpendicular bisector is a two-part word. The perpendicular part means it forms right angles. And we also know that perpendicular lines have opposite reciprocal slopes. And that's what's going to be important. And bisector, that part means that it splits the line segment in half. So that means the point that it's going to pass through is the midpoint of the line segment. And that's going to be important because that's going to be the point that our line's going to pass through. Notice from the drawing, the bisector doesn't pass through point J, it doesn't pass through point M, it passes through the midpoint of the line segment. So that's going to be important. We are going to need that. So first, let's find the slope because we need the slope and we need the point. So first, let's find the slope. So let's do the slope of JM. Slope is y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. That's negative 10 over 12. In simplest form, that's negative 5 over 6. So the perpendicular slope, the opposite reciprocal, if we flip it, we get 6 over 5. And if we change the sign from negative to positive, it's positive 6 over 5. So that already eliminates answer choice 1 and 2 because we need the slope to be 6 over 5. The midpoint is the point that we're going to be using. The midpoint formula is the average of the x coordinates, comma, the average of the y coordinates. So if we plug in negative 5 plus 7 over 2, 1 plus negative 9 over 2, we have 2 over 2, negative 8 over 2. So I have 1, negative 4. So when we're writing the equation of a line, when we have a point and the slope, we can use point slope form. It's a super simple way of writing the equation of a line when you have a point and a slope. All you need to do is plug in the slope for m and the x and y coordinate of the point that you're using for x1 and y1. So we have y minus, the y coordinate of the point that we're using of the midpoint is negative 4. Our slope that we're using is 6 over 5, x minus, the x coordinate of the midpoint, the point that we're using is 1. And minus minus does make a plus. So we're going to look for y plus 4 equals 6 over 5, parentheses x minus 1. And that's answer choice number 4. ABCD is a parallelogram. I'm just going to highlight that so I don't end up thinking that the whole quadrilateral is a parallelogram. EB is congruent to FB. I'm just putting them both in red. That's going to be easy for me to remember. And EF is perpendicular to FH. That means that when they intersect, they form a right angle. If angle E is 62 degrees and angle C is 51 degrees, what is the measure of angle FHB? So angle FHB is this angle right over here. So that's the angle that we're looking for. So what I do know is that in triangle EBF, if I just draw it separate for you, we were told that EB and BF are congruent. So we have an isosceles triangle, and we know that the base angles are congruent opposite from the congruent sides. So the base angles here would be this angle and this angle, so this would be 62 degrees. Since all three angles of any triangle add up to 180 degrees, I could also find the top angle of this triangle by doing 62 plus 62, that's 124, and subtracting 124 from 180, and that gives me 56 degrees. I also know that opposite angles of a parallelogram are congruent. So angle C and angle A are opposite angles of parallelogram ABCD. So this will also be 51 degrees. Using the fact again that all three angles of any triangle add to 180, I could find this angle over here because I now have two angles in this small triangle. So 56 plus 51 is 107. If I subtract that from 180, I get 73 degrees. I can still get closer to finding the angle that I need because I do know that this angle over here is a right angle, and I already found a piece of it is 62. If I do 90 minus 62, I can get the missing piece of that right angle to be 28 degrees. I can also use the fact that vertical angles are always congruent to get that this is 73 degrees. And then in this triangle over here, I can use the fact that all angles of a triangle add up to 180 to find the last angle. 28 plus 73 is 101. 180 minus 101 is 79 degrees. So this angle over here is 79 degrees. So now what I can do is I can use the fact that these angles have a linear pair relationship to find out the supplementary angle. So 180 minus 79 is 101 degrees. And these two angles here also have a supplementary angle relationship. So I can do 180 minus 73. And then I find that this is 107 degrees over here. So this is getting me a little bit closer to where I need to be. I also know that since ABCD is a parallelogram, the opposite sides are parallel. So that might help me find an angle relationship that might be true here. Because if I can find this angle over here, then I can get the one that I actually need. So all I need to do is find this angle over here. And since I do have that opposite sides of the parallelogram are parallel, I do see an alternate interior angle relationship here. Oh, sorry. I meant to highlight over here. We have a letter Z. So this angle is going to be 73 degrees. So using the fact that all three angles of a triangle add to 180, I can do the 73 plus the 28 and get 101 and then subtract from 180. And then I end up with 79 degrees for the angle that we're looking for. You definitely didn't need to find all these angles. I was just finding as many as I could along the way. If you put the parallel lines in at the beginning and found that alternate interior angle relationship, it would have been a lot quicker to get that answer. For 22, I'm going to need a little bit more space, so I'm going to do it at the bottom. So you're dividing a line segment in a 2:3 ratio. 2 plus 3 is 5, so that's 5 parts that you're dividing the line segment into in total. I'm going to just draw a picture. So it's line segment AB, and we're dividing into 1, 2, 3, 4, 5 parts. So what a 2:3 ratio means is that there's two pieces of the line segment, then the point you're looking for, which is P in this case, and then the remaining three pieces, the 2:3 ratio. So the point that we're looking for is going to be closer to A. So that means point A is going to get weighted heavier. The two weights that we're going to use are both going to have a denominator of 5 because we're dividing the line segment into 5 parts in total. And we're going to use the two parts of the ratio for the numerator. So one's going to get a 2, one's going to get a 3. And we're just going to stick a plus in between. So point A is where point P is going to be closer to. It's closer to A, so A gets weighted heavier. The heavier weight has the higher numerator, so 3 over 5 is the heavier weight. So point A is going to get 3 over 5. And point B is going to get the smaller weight, the less heavy weight. I like to now divide into X and Y coordinates. That way we don't mix and match them. I'm going to apply the 2 over 5 weight to both the X and Y coordinate from point B. The X coordinate from point B is 6, and the Y coordinate from point B is 4. And then I'm going to apply the 3 over 5 weight to both the X and the Y coordinate from point A. The X coordinate from point A is -4, and the Y coordinate from point A is -1. From here, all you need to type is the X's into your calculator and the Y's. If you type the X's into your calculator, you should get 0. And if you type the Y's into your calculator, you should get 1. So it's the point 0, 1. Notice how they put 1, 0 as an answer choice. So that's why I like to separate by the X and Y coordinates so you don't get that confused. A line is dilated by a scale factor of 1/3 centered at a point on the line. So anytime your center of dilation is a point on the line, the points are just going to shift up and down along the same line, resulting in the same line as the original line. So the image of the line and the pre-image are the same line is going to be the answer. 2 would be the correct answer if the center of dilation was the origin. 1 is never going to be the correct answer because dilations make parallel lines, so the slopes are the same. And for that reasoning, 3 will never be the correct answer either. The last multiple choice question, and this is a sector area question. So area of a sector, you're talking about the area of a part of a circle. So area of a circle is pi r squared, and I'm just going to put that here, area circle. And then you just need to multiply by the piece of the circle that you actually want, because you don't want the area of the whole circle, you just want of the piece. And the way that you do that is by taking the central angle over 360. I wrote theta here to represent the central angle, but I'm just going to write that that's the central angle. And that's the formula for sector area. So if I take a look at the question, we need sector DOE, the shaded sector. So the central angle that I need is the one from that sector. So angle OBA is 36 degrees. So they don't give us that. They give us an outside angle. OC is 10. So that means all the radii in the circle are 10. That's the radius. And we still need to get the angle that we need. So what's important to keep in mind here is when you have a tangent to a circle and a radius, they are perpendicular. So where radius OA and tangent AB meet, we have a perpendicular line over here. And then remember that all three angles in any triangle add to 180. So if I do 36 degrees plus 90 degrees, I get 126 degrees. And if I do 180 minus 126 degrees, I get 54 degrees. Vertical angles are always congruent, so that's 54 degrees as well. And now I have everything I need. So the area of the sector is pi, the radius is 10 squared times the central angle is 54 degrees over 360. Since the answer needs to be in terms of pi, because if you look at the answer choices, pi is in all the answer choices. When you type into your calculator, just don't put pi into the calculator. So 10 squared is 100. So I'm going to do 100 times 54 over 360. And I get 15. Just make sure you attach the pi. So that's going to be 15 pi. Oh no, what happened there? My app is looks like it was updating itself or something. Okay. So that is 15 pi. Moving on to the short response. We have a right triangle. We're finding a missing side. This is a trick question. So circle your focus angle. Could be any angle other than the 90-degree angle. Label opposite, hypotenuse, and adjacent. Write SOHCAHTOA on your paper. Since we have opposite and we're looking for hypotenuse, we want O and H, so we want sine. Sine of the focus angle, which is 86.03, is equal to opposite 183.27 over hypotenuse. You can put this over 1 and you can cross multiply when you're solving for a side. X sine of 86.3 equals to 183.27. To get the x by itself, you could divide both sides by sine of 86.03. Show out all your steps just in case you make an error. And into the calculator, I'm going to use the fraction button. Alpha y equals enter. 183, I can't remember what it was, 0.27 divided by sine of 86. Oops. Let me try that again. 183.27 divided by sine of 86.03. And rounded to the nearest hundredth, that's 2 decimal places. That's 183.71. Make sure that if you have time left over on your Regents exam, you go back and double check that you rounded according to the question. Okay. When you have a ratio, you can express the ratio algebraically. So arc CD is the first part of the ratio. So it's the first part here, it's the 2 part. So we can represent that as 2x. We can represent arc DA as 3x. We can represent arc AB as 5x. And we can represent arc BC as 5x. And you can do that anytime you have a ratio. That is represented all the arcs totaling the whole circle. And we know that in total, a whole circle measures 360 degrees. So if we take all the arcs and we add them together, we should get 360. Combining my like terms, 15x is equal to 360. If I divide both sides by 15, I get x is equal to 24. So since x is equal to 24, I can substitute into the arcs. I do know that we're looking for angle B. And angle B is an inscribed angle. Notice how its vertex is on the circle. And the endpoints are also on the circle, all 3 points on the circle. Inscribed angles are half their intercepted arcs. So the intercepted arc for angle B would be arc AC. That's where its endpoints are touching from A to C. So if I plug in for arc AD and arc DC and I add them up, then I can figure out what half of that is to get the inscribed angle, which is half of the arcs. So 24 times 3 is 72. So arc AD is 72 degrees. And 24 times 2 is 48 degrees. So 72 plus 48 is 120. So in total, this whole arc is 120 degrees. Inscribed angles are half their intercepted arcs, so that makes angle B 60 degrees. So the measure of angle B is 60 degrees. Make sure that you box your answer. We have a cone. We're finding the volume of the cone. The volume of a cone formula is provided to you on the Regents exam. It will look like this, 1/3 capital B times H. Capital B represents the area of the base. Since the base is a circle, the area of the base will be the area of a circle, which is pi r squared, and then times the height of the cone. We are given the diameter here, so that means that the radius is 5. The only problem is you're not given the actual height, you're given the slant height. Be careful, slant height, it's not the real height. We measure height with an altitude at a right angle. So we actually have to find what the actual height is. But luckily, we have a right triangle. If we pull it out really quickly, just to see it a little bit better, that's 13. That's 5, that's x. You can use Pythagorean theorem. I'll use a instead of x. So a squared plus 5 squared equals to 13 squared. A squared plus 25 equals to 169. A squared equals to 144. A is equal to 12. So the height is actually 12. So if we plug into the volume formula, the radius is 5. The height is 12. It does say to leave the answer in terms of pi, so we don't want to put pi into the calculator. So just type the numbers into your calculator and then just make sure that you stick the pi next to it. And this doesn't have units, so we're all good to go. Cubic units, whatever the units are. Use the properties of rigid motions to explain why parallelogram EFGH is congruent to parallelogram IJKH, and it says a reflection happened. So I'm going to write here, reflections are rigid motions, so they make congruent figures because they preserve side lengths and angle measures. They make congruent corresponding sides and congruent corresponding angles. And that's perfect. That's all you need. That's full credit. Just mention that they preserve side length and angle measure, and then you're good to go. The shape of the pendants here is a hemisphere. That's half of a sphere. Volume of a sphere is 4/3 pi r cubed. And then, of course, we're going to take half of that to get the hemisphere. So Izzy's making 100 pendants. Each pendant has a radius of 2.8. And we need how much clay? And these are all, everything's in centimeters, so no conversions needed. So all I need to do is type this into my calculator with a radius of 2.8. So 4/3 pi, the radius is 2.8 cubed. And then we need to half that because it's a hemisphere. So that's the volume of the hemisphere. And she's making 100 pendants, so just multiply by 100. And then it says to the nearest cubic centimeter. So that means the nearest whole number. So approximately 4,598. For the next one, we need to convert the equation of the circle from general form into standard form by completing the square. The way that we're going to do that is we're going to put the x terms next to each other. And I like to leave a box because something's going to go in the box. We're going to find what goes there. And then we're going to put the y terms next to each other. The 6y is on the other side of the equal sign, so I want to move it over to the same side. So when it moves over the equal sign, it gets a different sign. So it was a positive 6y, so when it moves over, it's going to be a negative 6y. Then I'm going to put a box because I'm going to find the number that completes the square. The 63, the constant, should be by itself on one side of the equal sign, so it's already in a good spot. And then whatever you add to the left, you do have to add to the right, else you'll end up with the incorrect radius. So please do make sure that you put the boxes on the other side as well, so you don't forget to do that. The way you find out what goes in the box, we'll start with the x terms first, is by using this nice formula, b over 2 squared. This is a, this is b. We don't have c, we're looking for it. So the b coefficient for the x's is positive 6. 6 over 2 is 3. 3 squared is 9. So 9 is the number that completes the square. That's going to factor to the same thing written twice because we made it into a perfect square trinomial. So like x plus 1 times x plus 1 or x minus 2 times x minus 2. The same factor repeated twice. The easy way to see what it factors to is the b over 2 before we squared it. So before we squared it, our b over 2 was positive 3. Now for the y terms, we're going to do the same thing. We're going to do b over 2 squared. For the y terms, we have a, we have b, and we're looking for c. A is negative 6. Negative 6 over 2 is negative 3. Squared is positive 9. So this is going to factor nicely again to the b over 2 before we squared it, which is minus 3. If we add the right-hand side together on our calculator, we have 63 plus 9, and we get 81. So now when you're writing down the center, remember it's opposite signs from what you see in the circle equation because the format for a circle equation is x minus h squared plus y minus k squared equals to r squared. So there's the built-in minus signs. So if we're seeing a plus 3 here, that means that the x coordinate of the center was really a negative 3 because that built-in minus sign changed it to a plus. And by using that same idea, if we see a minus 3 for the y coordinate, then that means the y coordinate was actually a positive 3. And on the right-hand side of the circle equation is r squared. So this 81 is actually r squared. So we do have to take the square root of it to get r, which is 9. Or you can leave it as radical 81. And that's our answer. The next one is construction. So I'm going to switch to my other my computer from my iPad. So give me 1 second. I'm going to replace my current sharing. Okay. And now I'm switching over here so that way I can do the construction. So we need a parallel line through point C. There's multiple ways to make a parallel line. So you may have learned a different way in fall semester, but I'm just gonna do the way that's the easiest in my opinion, which is making two lines perpendicular to the same line so that they're parallel to each other. Because just to show you where the idea is going to come from, if we have two lines that are both perpendicular to the same line, so both this line and this line are both perpendicular to this line, then that means they have to be parallel to each other. So that's the idea. We're going to make two lines that are perpendicular to the same line. And in my opinion, that's the easiest approach for doing this. So to make a perpendicular line, we're going to put our compass on the point that we want it to pass through. So that's going to be point C. I'm going to open my compass. It doesn't matter how much. The only thing that matters is when you swing an arc, you want to intersect the line in two spots. And I do want to say, since I'm doing this on the computer, yours is going to be a lot more, if you're doing it physically on paper, a lot more accurate than mine. Doing it by hand is definitely a lot more accurate. And then what I'm going to do is I'm going to go over to one of those intersection points. I'm just going to make my distance a little bigger, but it doesn't matter. Swing an arc. And then I'm going to go over to that other intersection point, and without changing the distance, I'm going to make the same exact arc. And then using my straight edge from where they intersect, I'm going to draw my perpendicular line. And as you can see, it should pass right through point C. That was actually pretty accurate for using the computer. Now we're going to make a line that is also perpendicular to this purple line. So not perpendicular to AB this time, but that's also perpendicular to the purple line. So I'm going to put my compass back on point C. And this time I want to do the same thing. I want to make the arc that intersects the purple line in two spots. So I just made it small so it's not messy. And you can see the two intersection points right over here on the purple line and right over here. So what I'll do is I'll just take my compass, I'll go over to one of them, and just to make it less messy, I'm just going to make my distance pretty wide here. I'm going to make an arc, and then I'm going to go over to the other intersection point without changing the distance and swing the same arc. And then using my straight edge, there we go. And that line is also perpendicular to this line. So since they're both perpendicular to the same line, they're parallel to each other. So we've constructed a line parallel to AB. Feel free to watch that as many times as you need to and to practice it, because if you don't practice it, it could be very tricky. I've practiced that a lot of times. So definitely make sure you practice. I'm going to switch back to my other screen now. For this one over here, we are finding the angle theta. You can't just make a trig ratio for this triangle over here because it's not a right triangle. And for trig, you need to use right triangles. Trig can find you missing sides and angles, but you do need right triangles. So what you can do, since you do have a right angle here, is you could use the small right triangle. And in the small right triangle, you can find this angle. And you can use the big right triangle. And then the big right triangle, you can find this angle. And then you could subtract the two to find angle theta, which is what you're actually looking for. If it helps, what you can also do is you can draw, oops, the small and the big right triangle separately. So on this one, we're finding y. On this one, we're going to find x. The right angles here in both of them. They both have 3.74 over here. And then in the small one, this is 0.41. And in the big one, we do have to add those together. So 0.41 plus 1.17 is 1.58. And from here, we can circle the focus angle. We can label opposite, hypotenuse, and adjacent. We can write SOHCAHTOA down on our paper. And for both of them, we have adjacent and opposite. So that's going to be tangent, O and A. So this is the small triangle. So small. And this is the big right triangle, big. So tangent of angle X, that's the angle we're looking for, is opposite over adjacent. When we're solving for an angle, we use inverse tangent of the tangent ratio, and that gives us the angle that we're looking for. For the big triangle, tangent of angle Y is going to be opposite over adjacent, and we're solving for an angle once again, so we're going to use inverse tangent of the ratio, and that's going to give us the angle. So just make sure when you're typing into the calculator, you do the big angle from the big triangle minus from the small triangle. And when you type that into your calculator, just make sure that you round according to the question to the nearest tenth. And to the nearest tenth, the answer to the question is approximately 16.6 degrees to the nearest tenth. For this one, we do need to write a proof. So by looking at the proof statement, and I always like to work backwards, we're proving that PT is congruent to RU. So those are sides of the triangle, and it's always going to come down to triangles. And it's always going to come down to either proving triangles similar or congruent. And since we're trying to prove that sides are congruent, we're going to prove triangles congruent. So once we figured out that we're proving triangles congruent, that's really half the battle. The only two triangles here are these two triangles. So these are the triangles that I'm going to be proving congruent. And then once I prove the triangles congruent, I'll know that the sides I'm looking for are congruent because once you have congruent triangles, everything about them is congruent. That's what it means for triangles to be congruent, that the side lengths are the same, the angles are the same, anything that's corresponding is the same because the triangles are exactly the same. And that's CPCTC. That stands for corresponding parts of congruent triangles are congruent. But what it just means in simple terms is that once you prove the triangle's congruent, everything about the triangles is congruent, all of the corresponding sides and all of the corresponding angles. So the hard part's going to be figuring out how we're going to prove the triangle's congruent because we have 5 methods. I'm going to write them down over here so we can refer to them. And we do need to figure out which one we have the information for. In the givens, they tell us that we have parallelogram PQRS that gives us a lot of information. Parallelograms have a lot of properties. I'm not just going to start marking everything right now. I'm going to read the rest of the givens and then I'll think about what can actually help me about a parallelogram in the triangles. Because sometimes if you just start marking everything you know about parallelograms, it makes your diagram very confusing. QT is perpendicular to PS. That means that they form right angles when they intersect. And look out for perpendicular lines because everybody should know that perpendicular lines form right angles. And even if you don't know anything else in this proof, if you correctly write down the right angles in your proof, that is 1 point you are guaranteed to get. SU is perpendicular to QR. And notice how there is a right angle on the other side. Same thing over here. But since I know we're proving the triangle's congruent, I need the right angles that are in those triangles. So that's why I marked the ones that I did as congruent. Now let me think about what I know about parallelograms that could help me. I know that opposite sides are congruent, and that gives me a side in the two triangles. And I know that opposite angles are congruent. And that's enough information to prove the triangle's congruent. We have angle, angle S, angle, angle side, AAS, two angles followed by a side. It's not ASA because the side's not in between the angles. It's two angles followed by a side. And be careful, just because there's right angles does not automatically mean it's going to be HL. Here we do have the congruent hypotenuses, but we do not have a congruent leg. We do not have a second side for it to be HL. We're all set. All we need to do is write this proof out. This one really was not bad at all. Make sure you put your givens. If you don't put your givens, they will take off points. You don't get any points for writing your givens, but you will lose points if you do not write your givens. You have 3 hours to take the Regents exam, so write down your given information. It is the basis of how you're making all of your conclusions anyway. Let's get those right angles. And now it's just transferring what's in the diagram to what's in the proof. So if whatever is marked in the diagram, that's going to be your statements. And then we're just going to put down the reasons for why each of them is true. So let's do the right angles. And I'm going to do them both in the same statement because they're both going to have the same reason because of the perpendicular lines. So angle SUR and angle QTP are right angles, and we knew that because of the perpendicular lines. Perpendicular lines form right angles. And if you just had that in your proof, just this and nothing more, if all you knew was the right angles, that would be a point. So that's why you can always get a point. Look out for right angles alternate interior angles. Those ones come up a lot, not here, but those come up a lot, especially if you have parallel lines. And vertical angles. Those ones come up a lot. We didn't have them here, but one of the three will always come up in every single proof. And here it was right angles that came up. But you can guarantee yourself a point if you just put perpendicular lines form right angles, and you can name your right angles with a three-letter name. Since we need congruent angles for AAS, we do actually have to say that those two angles are congruent to each other. And you can just say that's because all right angles are congruent. And that gives us one of our A's for angle side. Let's put our A in next, our second A. So angle R is congruent to angle P. And we knew that because opposite angles of a parallelogram are congruent. Parallelograms do have a symbol, but they're the only quadrilateral that does. And then finally, let's put the side in. You don't have to go in the order of angle, side, but I'm just doing it to make it a little bit more clear. RS is congruent to QP, and that was because they were opposite angles of a parallelogram. One of the parallelogram properties is that opposite sides are congruent. I'll just write in the parallelogram. And that's our side for angle, side. So now we have all the information that we need to prove the triangle's congruent. So I'm just going to say triangle RUS is congruent. Let me make sure I put the similar symbol. Is congruent to triangle PTQ. And we had determined it was going to be by angle, side. And now we can prove our proof statement. We can say that now we've proved the triangle's congruent. PT and RU have to be congruent due to CPCTC. Just make sure you get the letters in the right order, because once the triangles are congruent, everything else about them is automatically congruent as well. Okay, here we have a cylinder concrete footing, and the contractor is installing 10 of these. I already see a conversion is going to be needed because we have 4 feet tall and 12 inches in diameter. If we keep reading, a bag of concrete mix makes 2/3 of a cubic foot of concrete. So we need to change the inches into feet. There are 12 inches in there are 12 inches in 1 foot. So to convert from inches to feet, I just need to divide by 12. 12 divided by 12 is 1. 12 inches is just simply 1 foot. Volume of a cylinder is given to you on the Regents exam as capital B times H. The capital B represents the area of the base. The base of a cylinder is a circle, and area of a circle is pi r squared times the height of the cylinder. Let's plug in. The radius of the cylinder, they give us the diameter is 12. So radius would be the diameter over 2, half of that, which would be 6, times the height of the cylinder. Oops, I almost messed that up over here. We converted to feet. I was using the inches. We converted to feet. Everything needs to be in the same unit. We're using the height as 4 feet. We need to use the 1 foot. So 1 foot is the diameter. So if we divide that by 2, we get the radius. So that's 1/2. Or you can write 0.5 if you like the look at that better. I know some people like to look at 0.5 better than 1/2. And the height is 4 feet. So everything's in feet. So when you type that into your calculator, this will be in cubic feet. I'm going to type it into my calculator. Pi 0.5 squared times the height of 4 feet. And I'm going to keep a couple decimal places, 3.1416. So always good to keep like 3 or 4 decimal places until the end. So that is my volume of one of these concrete fittings. They are installing 10 of these, so I am going to have to multiply by 10. So on my calculator, I'm just going to hit multiply by 10, and I'm going to keep a couple decimal places, 31.416. So this represents the volume inside of 10 of these concrete fittings. Each bag of concrete mix makes 2/3 of a cubic foot of concrete. So we need to find the minimum number of bags needed to make all 10 footings. So all I need to do is just divide by 2/3, since 2/3 of a bag will each bag of concrete will cover 2/3 of a cubic foot. So I basically need to find out how many 2/3 of a cubic foot are in these footings to see how many bags I'm going to need. So let me divide by 2/3. I'm going to use the fraction button so my calculator doesn't get confused. And it says the minimum number of bags. So if I round it down to 47, even though it does round down to 47, there's going to be that 0.1238 of a footing left over that is not going to get filled with concrete. So I'm going to have to round up to 48 and then I'll have some leftover concrete, but at least I'll be able to completely fill the concrete footings that we're trying to fill with concrete, which is what the question's asking. It needs to completely fill them. It's okay to have leftover, but it's the minimum required to fill them up. So that would be 48 bags. And then we have a coordinate proof to end this. The grid is on the next page. It's a little bit further down. So I'm just going to use the grid over here to graph it. So A is -2, 1, 2, 3, 4. That's point A. B is -7, -1. C is -3, -3. And first up, we need to prove that triangle ABC is isosceles. So I'm going to try to find the length of AB and AC and hope that they end up the same so that I don't have to do BC as well. Because it doesn't say to prove it's not equilateral, it just says prove it's isosceles, and an isosceles triangle has two congruent sides. Be careful, slope formula does not prove equal sides. You do have to use distance formula. Distance formula, so to find the length of I forgot what I was doing. The length of AB and AC. So to find the length of AB, and then I'll do AC underneath. Distance formula is x2 minus x1 squared plus y2 minus y1 squared, all underneath the radical. So I'm using points A and B. So x2 minus x1 squared plus y2 minus y1 squared. In your calculator, just type in everything underneath the radical, just exactly the way that you wrote it down. So I forgot what it was. -7 minus -2 squared plus, just don't type the radical in, -1 minus 4 squared, and that's radical 50. Okay, let's do the same thing. I'm not going to rewrite the formula, but we're going to be using points A and C, so this point and this point. So x2 minus x1 squared plus y2 minus y1 squared. Type in what's underneath the radical into the calculator, and I'm going to just bring down the radical so I don't forget. Lots of people forget. -3 minus -2 squared plus -3 minus 4 squared, and that is 50 as well. So we have radical 50 for both the side lengths. Since AB is congruent to AC, the triangle has two equal sides, making it isosceles. If you don't put a sentence explaining what your work shows, how you know from your work it's isosceles, that it has two congruent sides, then you do not get full credit for this. And that is a bad way to lose points because if you know how to do it, you don't want to lose points for that. State the coordinates of triangle A prime, B prime, C prime. The image of triangle ABC after a translation 5 units to the right and 5 units down. So I'm going to just do that on the grid. 5 units to the right, 1, 2, 3, 4, 5, and 5 units down. Oops. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And just make sure, because it does say to state the coordinates, it doesn't count that you did it on the grid. You do need to go back up and state the coordinates of the points. So A prime was 3, -1, B prime was -2, -6, and C prime was 2, -8. And now finally, prove that quadrilateral A prime, so here's A prime, C prime. So it's in pink, the quadrilateral in pink. Prove that it's a rhombus. So in order to be a rhombus, we first need to prove it's a parallelogram. The way that I'm going to prove that it's a parallelogram is I'm just going to prove it's a parallelogram by showing that both pairs of opposite sides are parallel using slope formula. So I'm going to find the slope of A prime, and that should be parallel to the slope of CC prime. And then I'm going to find the slope of AC, and that should be the same as the slope of A prime C prime. And you don't have to use this method. You can use finding that the sides are congruent to prove it's a parallelogram. I just prefer slope formula. Just for my reference, A has coordinates of -2, 4. C has coordinates of -3, -3. A prime has coordinates of 3, -1, and C prime has coordinates of 2, -8. I don't like to keep flipping between the screens. So slope formula is y2 minus y1 over x2 minus x1. I'm going to use A and A prime, subtract the y's, subtract the x's, and if you put that into your calculator, you should get -5 over 5, which is -1. So when I find the slope of CC prime, I should expect it to be the same of -1 since they're going to be parallel. So I'm going to use point C and C prime, subtract the y's, subtract the x's. That's -5 over 5, which is once again -1. And now let's do it for AC, because I want to show that AC is parallel to A prime C prime. So for A and C, subtract the y's, subtract the x's, and I get 7. And I should expect A prime C prime to have the same slope. So subtract, this is A prime C prime. Subtract the y's, subtract the x's, and I get 7 once again. Now I need a concluding statement explaining what my work shows. Since both pairs of opposite sides are parallel, quadrilateral A prime, C prime C is a parallelogram. But I'm not done yet because I do have to prove it's a rhombus. So one way to prove it's a rhombus is you can show that two consecutive sides are congruent using the distance formula. Or another way is you can show that diagonals are perpendicular if you don't like distance formula and that uses slope. So I'm going to do that way because I actually don't really like using distance formula. So I'm going to find the slope of diagonal AC, and I'm going to find the slope of diagonal A prime C. Wait, well, that diagonal is AC prime. And then the slope of diagonal A prime C. And they should be perpendicular. They should have opposite reciprocal slopes. So for AC prime, I'm going to use point A and C prime. So -8 minus 4 over 2 minus -2. It's -12 over 4. That's -3. So I should expect the opposite reciprocal slope if the lines are perpendicular. So I should expect 1/3 for the slope of A prime C. So A prime C, subtract the y's, subtract the x's, that's 4/6, and that reduces to 1/3. Perfect. And now I need to put a concluding statement. Since diagonals have opposite reciprocal slopes, they are perpendicular, making parallelogram AA prime, C prime C, a rhombus. And that's it. That would be full credit. Not the only way to prove it's a parallelogram and a rhombus, but if you don't like distance formula, this is the way for you. As long as you know one way to prove that you have a parallelogram and one way to prove that you have a rhombus, you're all good to go. And that's the end. It's a long video.